Morning to everyone and welcome to a very special edition of the Gibco Galaxy Tour this year. My name is Lydia Gunn and I'm excited to be one of your hosts for today. As you may know, the Gibco Galaxy Tour has always been one of the star events of the year for us. And this year, of course, owing to the circumstances at present, we had no choice but to do it virtually. If this is your first time joining us, welcome. And if you are a returning participant, thank you very much for your continuous support. Today, we kick off part one of our tour, which is our education series, and I'm pleased to introduce Dr. Deborah Johnson, our R&D scientist, whose work focuses on the development of new products for cell culture. Dr. Johnson will be speaking about one of the most fundamental and critical aspects to consider when doing cell culture, which is the detection and prevention of contamination. Before I hand over the mic to Deborah, I'd just like to go through a few housekeeping items. First, on demand after the live session and is accessible through the same thermo-fisher link that you have received in your email. Next, we'd like to hear from you during today's presentation. If you have a question for our speaker, please feel free to send it through the Q&A box near the bottom of the screen. Our panelists are on standby to take these questions and we will also be addressing them verbally at the end of the session. And last, we'd like to encourage you to share any questions and feedback you have for us at a poll that we will open at the end of the presentation. All 4 participants will have a chance to win one of our 4 UV phone sanitizers at our lucky draw tomorrow. All right, I'm sure everyone is eager to start, so without any further ado, please welcome your first presenter for today, Dr. Deborah Johnson. Deborah, over to you.
Thank you so much for that introduction, and let's get started on one of my favorite topics, which is cell culture. Unfortunately, we all go through contamination issues, and that's what I'll be discussing with you today. I want to point out how to how to ask questions. So this is just a screenshot of what your WebEx screen should look like. And if you notice down on the right-hand side, there's a Q&A place where you can enter in your questions, and those questions will be sent to the speakers. So if at any time you have any questions, please let us know. I do want to make a mention that tomorrow we will be having another presentation, which is the Introduction to Transfection Basics. This will teach you about factors that can influence your transfection and how to make it more efficient, so please join us for that. So at Thermo Fisher Scientific, really our mission is to enable our customers to make the world healthier, cleaner, and safer. We do that in a lot of ways. My role, as was previously mentioned, I'm an R&D scientist. I do product development. My main focus is on cell culture plastics and also cell culture medium. So I'm here to answer any of those questions related to that. And with that, we can dive right in. So here's an outline of what I'm going to cover. Just some common types and sources of contamination in your cell culture, detection methods, examples of contamination, antibiotics and how to use them properly, how to prevent contamination, if you do get contamination, how to actually decontaminate your culture, and then some best practices, do's and don'ts. And to finish up my presentation, I'm just going to cover some of our newest products and how they can really help you in the lab to make your workflows easier. So there are several different types of contamination when we're talking about cell culture. Some of these are more chemical contaminants, which are listed across the top of the slide here. These can be introduced into cell culture through inferior reagents, plastics, or consumables. So these low quality products may contain residues or dust. So it's really important that you choose high quality products that have been through a rigorous QC testing, quality control testing. Biological contaminants, which are listed here across the bottom of the slide, are also very frequent in occurrence. The more frequent ones are the bacteria, the yeast, and the mold. The less frequent are the insect cells and other mammalian cell types. An unclean laboratory and also improper use of the aseptic technique will increase the likelihood of biological contaminants. And today we're really going to look deeper at these biological contaminants, how you can identify them, how you can detect them, and most importantly, how to get rid of them. So this next slide just shows a laboratory. This is actually an R&D laboratory inside Thermo Fisher, and it really just points out some common areas of sources of contamination. So the water bath shown all the way on the left-hand side is a really good source of contamination. Also the incubators sitting next to it, you can see in, highlighted in the green text. Both of these environments are warm and moist, providing just a great place to grow and spread bacteria, mold, and yeast. Another source of contamination is centrifuges. So centrifuges are often overlooked when we're cleaning the lab, but they very easily aerosolize contaminants that can infect your culture while you're using the centrifuge. It's really important to keep them clean. Another one is a microscope. We probably, in doing our cell culture work, use the microscope on an almost daily basis. It's also used by multiple users in the lab. It's really critical that we keep this clean. Other items that should be considered in your lab include, your lab coat, your cell culture vessels, and your pipettes. You want to make sure all of those things are clean when they're in use and when you're pulling them in and out of the hood. Special attention should also be given to the air vents and the cleanliness of the floor. All of those can affect the quality of your cell culture and how many particulates actually get in while you're trying to keep your cell culture as clean as possible. It's also really important to provide adequate spacing in your lab so that the airflow is properly moving and really to have a clutter-free environment. That's not just for contamination, that's for everybody. It's nice to be organized, and of course you want to keep as much clutter out of the lab as necessary. If you don't need it from the lab, remove it from the lab. So there's several different ways that we actually detect contamination inside your cell culture vessels. The most probably obvious one is just a visual or a microscopic inspection. These are really effective, right? And something you can really do on a daily basis. It's very easy and straightforward. So visual inspections are critical and what we're looking for is actually cloudy, medium, or unidentified objects inside your cell culture. You also want to use the microscope to look at your cells and make sure that they have their characteristic shape and that they're growing at the right rate. Another commonly used detection method is PCR. This is widely used for mycoplasma detection and viral infection, but can be used for several other things. Another way that we detect contamination is through fluorescent dyes. These are also commonly used for bacteria. I will actually go into one of these in a little more depth, which is used to detect mycoplasma inside your cell culture. Growth rates are another way to keep track of your cells. So, growth plates are another way to keep track. So keeping these plates just in different areas within the lab and checking them on a regular basis to make sure they're not growing any bacteria, fungus, or yeast. This just gives you an indicator of really how clean your lab is on a general sense, right? So just having those plates set out somewhere, if they do become contaminated, you know that you have a cleanliness problem. There probably needs to be some decontamination happening in the lab. And the last thing that we have here for a detection method is karyotyping. So karyotyping is used to identify cross-contamination between cell lines. This is more of a rare situation, but it's really important to keep in mind while you're doing your cell culture. You want to make sure that the cells you think you're experimenting on are the real cells that you are experimenting on. This slide shows just sort of on a visual level what you should be looking for in your cell culture. So up here on the left top, we actually have yeast contaminated cultures. And yeast makes the media very turbid. It's very cloudy, right? More cloudy than if it was just your cells. The problem with yeast is it doesn't always have the giveaway of changing the pH in the media. So we'll go a little bit more into that into detail. We have some fungus contaminated cultures here on the right-hand side at the top. Fungus actually gets quite large. It's pretty easy to see in its advanced stages. Down here at the bottom left-hand, we have bacterial contaminated cultures. Bacteria is notorious for changing the pH on your cultures. So if you see a pH shift that's too dramatic for just your cells alone, that usually points to a bacterial infection. And down here on the right bottom hand side, we have uncontaminated cultures. So it might take a little bit of practice to understand the difference between turbidity from your cells and turbidity from a contamination issue. Okay, but that's something that you need to, it's a really good practice to look at your cells every day so you know that what they look like on a normal basis, and you can determine if they have become contaminated or are unhealthy in any way. So we'll get a little bit more into bacterial contamination. This is usually easily detected using just a visual inspection, and it is very apparent within the first few days of infection. This is by far the most common type of contamination we see in the lab. Like I said, the media gets a little bit turbid, and it also causes a severe drop in the pH. So here we just have some images of some cells. So these are 293 cells contaminated with E. coli. E. coli are just typically a rod-shaped bacterium. And you can see from this illustration that at low power, they're a little bit difficult to see. So I would encourage you to, when you're checking your cells for confluency, you also want to zoom in and make sure there's nothing floating or growing around the cells. So it's really important to look at them on a wider scale for confluency, and then to zoom in to make sure there's nothing growing in there that shouldn't be growing in there. So this is a little bit clearer of what potential bacterial contamination can look like. So you see we have these 3 blue boxes outlined on this image of these cells. So the one box is just 1 to 2 cells. The medium box is a chain of about 8 to 10 bacterial cells. And then the largest box is actually a cluster of bacterial cells. I am going to play this video here. And what we're looking at is these little specks. They seem to be moving around. They actually have flagella that propel them through the media. So you should really take some time, spend some time with your cultures, look at them not only, like I said, for confluency, but zoom in and make sure that there's no small little critters growing in there. So yeast is another type of contamination. Yeast is a unicellular microorganism. They have a wide range of sizes, but like I had mentioned, they really make the media very turbid. We don't usually see a severe drop in pH for yeast, and that's usually how you can distinguish whether you have a yeast or a bacterial contamination. Bacteria will make the pH change. Yeast usually makes the pH stay about the same. Especially in the early phases of infection. So we have, again, some close-up images here. You can see the yeast cells appear as little particles that actually bud off from each other, and you can see them attached in a little chain. These are very clearly not mammalian cells. So if you spend some, like I said, spend some time with your cell culture, look closely, you'll see that these are distinct individual cells. It's hard to mistake them for cell debris. Right? They do look like organized structures. Another common contamination is mold contamination. So I know where in the area where we do cell culture, we actually have an increase in mold contamination during the summer. I think that's common in some other areas too. So make sure you're aware what season it is in the lab that can increase your contamination levels. You want to be very careful during those high contamination times, right? So mold is, it grows in more of like a filament type of pattern. It almost looks like strings inside your cell culture. They look like, little waspy filaments. Sometimes they can be mistaken for, hairs or particulates, but they do rapidly increase and grow in size. They can be a little bit tricky. They don't always affect the health of your cells, but of course, this is a variable we don't want happening in our cell culture. We don't want to add anything to the experiment that we weren't expecting, right? So look out for these for mold contamination. Another bacterial contamination is mycoplasma. So mycoplasma is probably more common than we would all like to admit. They are very, very small, simple bacteria, can't be seen by eye. They also lack a cell wall, so they don't really respond. They don't respond to the antibiotics that we normally use for cell culture. They can't be filtered out. And really the best practice is to routinely check your cell culture for mycoplasma. There are several ways to do this. One really easy way that I have found to do this is to use this mycoflora mycoplasma detection kit. So this kit will readily stain the nuclei of the mycoplasma. And what you end up seeing is you have DNA in the extracellular space of your cells, right? So that's where the bacteria is actually inside the cell. And of course, you can see in this picture all the way to the left-hand side, in healthy cells, you should only have DNA labeling inside the nucleus, right? So this is very easy protocol. It takes less than a day, can really be done by anyone. There's no reason not to really have this on a regular basis, making sure that your cells are mycoplasma free. Okay. There we do have another option, which is the MycoSeq mycoplasma detection kit. So you can see it over here on the right-hand side of the screen. This is actually based on a real-time PCR assay. So it'll give you a much clearer evidence that you do have mycoplasma infection. Virus contamination can also occur in your lab. Of course, I think a lot of us know viruses can't be seen with light microscopy. They're very difficult to detect and difficult to remove from any cell culture or any reagents. If you are working with viral particles or any sources that might have viral contaminants, it's really important that you first look out for your laboratory personnel, right? We don't want anyone in the lab to be infected from a virus that came out of cell culture, and then also to protect your cell culture itself. Viral infections can really only be detected using electron microscopy, immunostaining with multiple antibodies, an ELISA assay, or PCR. Okay. So this is sometimes a unique problem. I don't think all of us run across the opportunity, the fact that there might be a viral contamination. But if your lab does have those circumstances, it's really important to pay attention to that, because we can't see viruses, right? So you have to do a little more work to make sure that your cell cultures aren't contaminated with viruses. This is just a little quiz that we've devised. So we've learned about these things. If you guys want to go ahead and try to answer this question, you can in the Q&A box. What I would like you to do is try to identify what's in photo A, what's in photo B, what's in photo C, and what's in D. Okay. So if you look at A, we have nice organized filaments growing, right? If you look in photo B, we actually have this is a fluorescent stain of cells. And then in C, we have nice rod-shaped dark structures. You can see they're surrounding outside the cells. And then in the last photo, we have these little black dots that are just sort of around the cells. Give you guys a few minutes if anyone wants to participate. Okay, so photo A is actually a fungus or a mold, and we can tell from the nice filaments that it grows into. Photo B is actually a detection of mycoplasma. So again, we see that nuclear staining inside the extracellular space. Photo C is E. coli. So they have their nice rod-shaped bacteria. If this was a live culture, you could probably see the E. coli moving around. You can sometimes see it enter cells too. And then photo D is actually normal cell debris. Okay, so there's no infection here. One way that is really easy to tell that is when you're looking at your cells, you put them under the microscope and you just stare at them for about 10 seconds. And if the small debris isn't really moving, it's probably not alive. It's probably just cell debris. The other thing to keep in mind about cell debris is it's usually irregular in size and shape. You can tell that the E. coli has a very nice consistent shape between each E. coli particle, but cell debris has differences, right? Some of it's small, some of it's large, and cell debris is normal. Cells die and go through their normal processes, so it is okay to have some cell debris in your culture. Okay. There's a tip down here, which is just to try to avoid bacterial contamination. A lot of people routinely use antibiotics in their culture. We also have another product which is called anti-anti. It's very effective in preventing not only bacterial but also fungal contamination. So like I mentioned, in those summer months when the mold spores reach their peak, it's really nice to have this reagent around to keep the bacteria and the fungus at lower concentrations. Okay. So that brings me to my next issue, which is actual use of antibiotics. Okay, it is really nice to have antibiotics to really prevent bacteria contamination in the lab, maybe poor use of the aseptic technique. But we want to make sure we're using them responsibly, right? So you always want to try to use antibiotics at the lowest level possible, and make sure that you pick the right antibiotic for the assay or the experiment that you're doing. So we have here listed a bunch of different antibiotics and the types of bacteria that they work against. I think we all know that antibiotics in any situation come with advantages and disadvantages. So some advantages are they prevent contamination. They can also be used to decontaminate a culture. And they're really useful when we want to have a method of selection, right? So we can transfect in an antibiotic resistant plasmid and select for cells that haven't been transfected. They do come with some disadvantages, right? We don't want to help develop any antibiotic resistance, so it is definitely not a good idea to use them when not necessary. They can also mask a low-level infection, so maybe if your antibiotic concentration isn't quite high enough or your antibiotics aren't very effective, they can mask an infection that might be happening inside your cell culture. They can also be toxic to cells. Okay, so not all cells are able to grow in antibiotics, for example, stem cells. Also, if you use them at too high of a concentration, the cell cannot survive in those conditions. So it's really important that you think about your cell model system, how you're going to be using it, and what the best option is for your antibiotic use. Another type of contamination that we don't discuss very often in the lab is actually cross-contamination. So this is when one cell type infects or contaminates a culture of another cell type. Okay, this is, I think it happens more than we would like to admit. It's really important as a researcher that you obtain cell lines from reputable cell banks, that they have a history of where they obtained these cells, right? You should also regularly check the characteristics of your cells and practice the good aseptic technique. Some sort of critical things, especially when you're beginning cell culture, it's a good idea not to have two different cell types in the inside the biosafety hood at the same time. So just keep them completely separate. It's also good to have separate reagents. So you don't want to share one, for example, medium bottle with one cell type with another cell type. So make up a medium bottle for each cell type that you have in culture at that time. Okay. If you are worried about cross-contamination, there's a couple of different things. You can make sure that your cells are what you think they are. DNA fingerprinting, karyotyping, isotype analysis, all of those can help you confirm that you have the cell type that you want or need. So another aspect that I think a lot of people don't talk about is what happens when you do get contamination. So if you come across a culture that has a bacterial, yeast, or mold infection, it's ideal to stop that immediately, right? You don't want that going around the lab. You definitely don't want to leave contaminated cultures inside the incubator or inside the biosafety hood, because you're really increasing the likelihood of infecting another culture. Okay, so you want to, like I said, isolate that, take that out of this tissue culture room if you can. If not, you just want to add a bleach solution, about 5%, and incubate it for about 5 minutes. It doesn't take much. It's probably just enough bleach solution to cover the bottom of the flask. And then you want to immediately discard that. So I know certain institutions have different disposal methods for bleach, so make sure you're following the disposal method for your institution. But it is really imperative that you get that away from other cultures as quickly as possible. So what happens if you do get contamination, right? And you can't dispose of those cells? Let's say it's a really important cell line. You don't have access to any more of those cells. We don't recommend decontaminating, but it is possible. I have done it myself before. We actually made a knockout cell line, and we got some contamination in it and had to go through decontamination process. I will say the cells came out the other side and they seem to be just fine. Okay, so here we present a decontamination method using suspension culture. Really what you want to do is you want to prepare a new medium that contains 5x or 10x the normal concentration of antibiotics that you would use. This is a pretty high concentration. And then what we recommend is that you grow the cells in this high antibiotic concentration for at least 3 passages. Some people recommend up to 5 passages. Okay. If you run across a media type that you actually have found some contamination in, we do have these Nalgene rapid flow filters, so they can help you filter out larger contaminants. Obviously, this won't work for mycoplasma contaminants. There are some mold spores that are small enough to get through the filtration. So this isn't always the best method, but there are a lot of bacterial types that you can get them out through filtration. So of course, just like suspension cultures, there's also problems if you want to decontaminate an adherent culture. So the recommendation is the same, right? You want to add a 5 or 10x higher concentration of antibiotics than you would normally use. You want to passage the cells for at least 3 passages, and just follow your normal passage method. It's really important that you just check on the cells on a regular basis to ensure that this much higher concentration of antibiotics isn't hurting your cells in any way or damaging them to the point where they can't recover. You want to find a sort of a balance of you still have your healthy cells, but you're killing off the bacteria or yeast or fungus that's in your culture. Okay. And then one tip here that I want to mention is just the use of the Gibco one-shot FBS bottle. I'm going to go into a little more detail on this product in some upcoming slides, but this bottle is basically pre-aliquoted FBS. So I know I've spent a lot of my lifetime in the hood aliquoting FBS, right? It usually comes in a big 500 ml bottle, but we only use it 50 mils at a time. So what Thermo Fisher did was they conveniently put it into a 50 ml bottle, and they didn't make it so expensive that you can't afford it. Its prices are actually very similar to the 500 ml bottle, which is probably my favorite part about the product. But it comes in this very convenient bottle. You can just open it up and put it right in. It saves you the time of aliquoting, and it also reduces that risk, right? When you're aliquoting, of course, you're opening yourself up to the risk of more contamination, and this takes that out of the equation. Okay, so we have just here some more lab do's, right? We'll go over the do's and don'ts in the lab. So of course we want to wear protective personal equipment. Okay, you always want to make sure you have your lab coat on, make sure that you have your gloves on. It's really important that your gloves cover the cuff of your lab coat so that you don't have exposed skin where particles can fall off, or bacteria or yeast or whatever can come from your skin into the culture. Of course, you want to have your hair tied back. So hair is pretty dirty. It has a lot of yeast and bacteria growing in it itself. You want to make sure that's tied back. Of course, keeping your workspace organized. Especially inside the biosafety hood is dependent on airflow, and if you have too many things inside the hood, the airflow can't work properly, and you are opening yourself up to a huge contamination risk. Okay, I think we said several times before, of course, you want to monitor your cultures on a regular basis. Disinfect surfaces regularly with 70% alcohol. And then, like I think I mentioned in one of the earlier slides, of course, you always want to clean and sterilize your water bath and your incubators. Okay, that should be happening on a regular basis. I know at Thermo Fisher, we try to clean both of those out at least once a month, and that seems to work pretty well for us. Okay. Down here on the right-hand side of the screen is this Gibco bottle weight. So this weight is specially designed for the Gibco bottles, which have a little bit of a unique shape. But this just makes sure that the bottle stays upright inside the water bath. So maybe you only have, a little bit of media left in the bottom. You want to make sure that bottle doesn't tip over inside the water bath. So this weight will help it stay upright. So now here's some of the don'ts of the lab. I think a lot of us forget this first one. You really shouldn't talk, cough, or sneeze while you're performing aseptic techniques, right? You shouldn't talk into the hood. Like I said, it's dependent on airflow. So if you're speaking or coughing, you can actually disrupt that airflow. In general, it's a good practice not to share media or reagents. Not only does that, it helps protect all of the cell culture, right? If it's much worse if everyone in the lab gets contamination versus only one person getting contamination. Take your time with experiments. The quicker you go, the more likely you are to mess up. Okay. We talked about overuse of antibiotics or the wrong choice in antibiotics. It's really important that you pay attention to what you're using and how you're using it. Okay. And then, of course, it's not advisable to use non-sterile labware or consumables, or even lower quality consumables that haven't been through a good quality control process. Okay, you're again opening yourself up to a potential contamination risk. Another thing is, I don't know how many people are aware of this, but cardboard boxes in particular are very dirty. They harbor a lot of bacteria. They also release a lot of particulates. In general, they shouldn't be stored in the lab. So try to keep the cardboard boxes or similar materials away from any lab materials. So we do have some products that are specifically designed in mind to prevent contamination. So up here at the top left-hand screen, we see the Lab Armor beads. So these beads replace the water inside your water bath, but they still have the same effect of heating up anything that you put inside the water bath. It's a really cool invention. Of course, we have the Easy Flask that we use. The Easy Flask has a specially designed opening on the flask, and it actually makes for a quicker turn, open and close. So obviously the shorter amount of time you have your flask closed, the shorter amount of time you fumble with the cap, the better off you are in preventing contamination. Again, here's the little one-shot bottle that I showed you. It just says, eliminates the need to aliquot for FBS. The rapid flow filter units that we discussed for any medium or reagents that may have become contaminated, you can put them through the rapid flow filters. And then, of course, we have the MycoFluor and MycoSeq mycoplasma detection kits. I can't stress how easy the MycoFluor kit is. I do use it on a regular basis, and it works very well. And that will sort of point you in the right direction whether or not you need to do a more thorough investigation of a mycoplasma contamination in the lab. So it's a lot of information when you go into the lab and you're trying to keep track of all the things you need to do for the aseptic technique and making sure your cultures are clean. So what Thermo Fisher has done is put all of these things into one place, right? So we have a downloadable checklist, and you can go through. This is really nice to just have somewhere near your biosafety hood. You can go through this every time. You sort of get into a routine after a while, and you know what's expected of you. This is just a great way to keep track of everything, right? The other thing that we have is a cell culture basics learning resource. This is a great website. I have been doing cell culture for at least 10 years. I still go here and make sure that I'm up to date on my basics, right? This is also a really good place to find more information on cell culture contamination. So any of the issues that I've discussed here today, you can go get more information on this website. Maybe you want to share it with a friend, let them know what you learned today. This is another great website. So for the last section, I just want to talk about some of our other more innovative products. It's really cool to be behind the scenes in Thermo Fisher, thinking about these products, how we can make your guys' lives easier, how we can get you through your workflows smoother. And I know my goal in product development is to take away another concern that scientists have, right? So as a scientist, you're concerned about how this mechanism is working, or you're concerned about how well your model represents what it is you're trying to model. So I like to be the one to take out other variables, right? I would like the media to be consistent every time you buy it, the FBS to be consistent every time you buy it. And I think Thermo Fisher puts a lot of pride behind that level of quality. So I'm going to cover some of these products here. We have the bench stable media, advanced reduced serum media, Glutamax, Triple E, and Florabright. Yeah. Some of the other, just as a product family, obviously, you guys, I think you know, we offer the cell culture media, the FBS. While I've only discussed the one shot today, of course, we have different types of FBS. We have standard, high performance, specialty FBS, really any type of FBS you need for your application. Several different cell culture plastics. So like I mentioned before, I'm actually in cell culture plastics development. All of our cell culture plastics go through a very stringent QC test. They're actually tested against 4 different cell lines to ensure that the plastic we're sending you is what we say it is. Okay, we want to make sure that once it gets to you, it does its job in growing the cells appropriately. Of course, and then our transfection reagents, which we're going to go into more detail tomorrow in the next presentation. So the first product I want to get into in more depth is actually our bench stable media. So this medium was developed actually as part of my team. So it was really interesting to see how this came along. This medium can be stored at room temperature. It really frees up a lot of refrigerator space. It's really easy to use. It's a direct replacement. So there are different types. For example, it's a direct replacement for the DMEM media that you're keeping in your refrigerator right now. And it is also comes in a light protection packaging. So each individual bottle comes in a box. And this box is actually lined in black, so it inhibits more light from getting in. When I started using bench stable media, I actually freed up an entire shelf inside my refrigerator, which was great because I think in most labs, refrigerator and freezer space is very valuable. So all of my media sits on the shelf nowadays. It was a little bit different in the way of thinking, but it works really well. So some of the data that we gathered at Thermo Fisher just to ensure that this light stable media would provide you with the same results that you previously got with refrigerated media was we grew different cells, both long-term and short-term, in bench stable media and in refrigerated media. And you can see here we have a bunch of different cell types: HeLa, Hex23, Jurkat, the SHSY5Y cells. And then on this side, we have grown actually in MEM media, MEM media, or DMEM media, RPMI, and then we have the DMEM F12 right? And the A549 cells, MCF7s, THP1s, CHO-K1s. So not only did we test it in adherent cultures, but also in suspension cultures, and we really found no difference between this bench stable media that they created and the refrigerated media. The next test they did was while they were in development, they looked at how light degrades media. Okay, so you can see on this graph here on the left that they exposed media to light and then looked at different components of the media. So obviously, some components are more drastically affected by light than others. The one that we ran into that was a big problem was the thiamine and the riboflavin. So once we took this light exposed media and tried to grow cells in it, what you can see from this graph on the left is that when we protect the media from light, cells grow at their normal expected rate. But light exposed media, because it has been through some degradation, does not provide the growth support that we would hope for. So I think the team in development, we found that the cells grow normally, but we also wanted an actual functional readout, right? So they also tested this bench stable media in a transfection experiment. And as you can see from the left, it's been quantified too by the graph. Transfection efficiency did not change in refrigerated versus bench stable media. And then to take that one step further, they actually differentiated the SHSY5Y cells. And you can see there was essentially no difference in differentiation with refrigerated or bench stable media. So all of this data taken together, we feel is it gives the customer or gives you guys a lot of confidence that when you take this refrigerated media or use this bench stable media, this room temperature media, that there is no change in your cell growth or functionality of the cells. I think this is the last data piece that we got from the bench stable studies was looking at oh no, I'm sorry, this is not the last one. This is not the one I wanted to go to. Oh yes, mitochondrial staining, right? So just overall, how is the health of the cells? The mitochondria is usually a good readout of how healthy your cells are, that they're in the right place, that they're have the right density, things like that. And again, what we saw was there was no big change between refrigerated media and bench stable media. Okay, now to shift gears a little bit from the bench stable media, actually I want to add one thing. While the basal media itself is stable at room temperature, once you supplement this media with FBS, it does need to be stored in the refrigerator. Okay, so FBS is not bench stable, and it will quickly degrade if you leave it at room temperature. So this is more of a fix for a long-term storage for your basal media types. Okay. So moving on, we sort of discussed the one-shot FBS system, right? It comes in a small bottle, eliminates the need for you to aliquot. You can see up here at the top is the workflow for actually aliquoting. So you have to get the FBS out. You need to thaw it. You need to sometimes heat and activate, and then you need to get all of the 50 ml conicals out. You need to make sure they're labeled properly, and then fill them all up, and then put them back in the freezer. So it's a big process. It's an important process. FBS is absolutely critical, right? But really what Thermo Fisher did was take that work out for you. They put it into this little one-shot bottle. All you do is pull it out of the freezer, you let it thaw, and it thaws much quicker than a 500 ml bottle. And then you can just pour it directly into your cell culture media. I use the one-shot bottle every day. I actually used 3 of them this morning. This is by far one of my favorite products. Saves me a lot of time. I wish I had had it during grad school. Another really really nice product, this is also one of my favorites, is actually the EEE dissociation reagent. So this reagent really takes the place of trypsin. Okay, so trypsin is an enzyme and it works by basically degrading the cell attachments around the outside of the cell. Okay, so EEE is similar to trypsin, but it's a little bit more gentle. Okay, and one way that we proved that was we treated, you can see over here on the panel on the right-hand side, we actually treated cells with trypsin, which is represented here in the right. So you have an untreated cell peak, a 20-minute treatment, a 10-minute treatment, and a 5-minute treatment. And then what we looked at was just cell surface labeling of CD2. Okay, and you can see the longer you keep your cells in trypsin, the more CD2 you lose off of the cell surface. In comparison to the EEE, which is shown here on the right in the blue, there really is no difference between the 20-minute treatment and the 5-minute treatment. So it really is much gentler on your cells. The other thing is it doesn't have to be frozen, right? You don't have to thaw it. You don't have to aliquot it. It's stable at room temperature. And of course, it is animal origin free. So if you guys are doing anything in the cell therapy space, this is a really good tool to have because it's not derived from any animal products. Another really nice cell culture reagent is a Glutamax supplement. So glutamine comes inside cell culture medium. So, it's of course required for cell growth, but glutamine is not stable inside cell culture medium. So Thermo Fisher created Glutamax. It's a direct replacement for L-glutamine, and it also helps minimize ammonia buildup as it's not processed in a similar way. It's really easy to use. Again, this one is stable at room temperature, so no aliquoting, no freezing, no waiting for it to thaw, and it works really well. We've done extensive studies as far as cell growth goes, viability, things like that. There's no change in cell growth or viability, but over a 12-month period, it's much more stable. So I highly recommend, if you have the option to buy RPMI with glutamine or RPMI with Glutamax, I really recommend the Glutamax supplement. Again, it takes out another variable. You don't have to worry about, do my cells have everything they need to grow, right? They have the Glutamax, so you know that that's going to be stable over the long term of your cell culture medium. Another really nice addition to your cell culture reagents is recovery cell culture freezing medium. So I know years ago I would actually have to make my own cell culture freezing medium. Everyone in the lab sort of had a different recipe. I think all of our cell banks were a little bit different. This really takes the guesswork out of that. I've used recovery cell culture freezing medium on several different cell types, primary cells, cell lines, had great cell recovery. This is also ready to use, right? There's no need to combine everything. This one does have to be frozen. This one is not stable at room temperature. But you can see here from some data that we collected, we basically compared other growth mediums that are out there on the market. And the recovery medium is shown here in the pink color, which is the bar all the way to the left. And you can see that when we compare ourselves to other mediums on the market, we do quite well as far as cell recovery goes. This is a great, very convenient product. Like I said, it really increased our user-to-user, it decreased our user-to-user variability when we started using the recovery cell freezing medium. And getting towards the end here, this slide is all about cell culture plastics, right? So the cell culture plastics that we use are branded with the NUNC name. We have a big portfolio, a lot of different cell culture plastics to choose from. I had mentioned earlier that when we produce one of these cell culture plastics, we actually certify it with 4 different cell types. We provide proof of that. You know, there's a certificate in every single case. You can tell that the case has been irradiated. It's been gamma irradiated. All of our products are, of course, USP and non-cytotoxic, right? So we have to meet these certain requirements that you can use these for research, and they're not cytotoxic. They're not going to kill your cells. Some of our requirements are actually listed here on the right-hand side of the slide. So what we look for when we produce one of these plates before we get this plate out to you guys is we look for a less than 10% growth variation in 3 different cell lines, the L929 cells, the HEL299, and a primary chick embryo cell. And then we also look for a variation in a colony forming cell line. So a lot of work goes into producing one of those plastics. For my last slide, I actually want to present to you guys, I want to show you one of our cell counters. So this is an automated system. It's very simple. You just load your sample onto a slide, you put it in there. It has an autofocus, helps to reduce user-to-user variability, and it gives you all of the information that you need, cell counts and viability. The last system that I want to mention to you guys, sorry, I'm hurrying through, I'm running out of time here, is the EVOS imaging system. I love the EVOS. It's a great tool in the lab. My favorite feature is that it has a big screen, so everyone in the lab can stand around the screen and see exactly what I'm seeing on the microscope. The EVOS system comes in several different layers, right? So you can get a very basic EVOS or a more advanced system like the one that's shown here. This system has a really cool feature. It can actually measure confluency, and it allows the user to adjust how it measures. So this is just an example of the screen that you would be looking at. And you can change how it's measuring confluency, or, you know, tweak your mask so that it fits your cell type and your experimental conditions. This is, again, one of my favorite products. Love the EVOS. Very, very useful in the lab. So I would encourage you guys to look into the EVOS. It makes your cell culture life work a lot easier. This last slide is Gibco education tools. I want to point out one thing is the media formulation tool. Gibco actually has the ability to formulate custom mediums for you. So please check that out if that's something you're interested in. The other thing we have is a, oh, I see the Gibco cell culture basics on here. That was the other one I wanted to print out. Great for new users. If you have a new user, or maybe you need to refresh your skills, cell culture basics is a great website to visit. Yeah. So at this time, please add any questions to the Q&A box. It's shown again here on the right-hand side.
Thank you, Deborah, for the presentation. So because we are running a bit short of time and our panelists have been hard at work answering all the questions, so I'll just read out one question that is still not answered yet. And a minute. So from Winnie, what is the best practice for cleaning recycled glassware bottles to prepare powder media?
I'm sorry, you said for recycling glass bottles?
Yes, for cleaning recycled glass bottles.
Oh, okay. That's an excellent question. So I know where I work, it's actually site dependent. Okay, so in my last lab, we did have a very strict cleaning protocol that we followed. In this lab, it's not quite as strict. So I would really encourage you to reach out to your, it's usually an environmental health and safety officer or someone on your site that's responsible for waste disposal, and ask them what the appropriate method would be for your site.
Thank you, Deborah. So over to you, Sonia.
All right. Hi, Lydia. Can you hear me?
Yes.
All right. Hello. Good morning, everyone. I'm Sonia from Thermo Fisher. Right now it's poll time, so please look to the right side of your screen where we will kickstart our polling session for today's session. So after you heard about Dr. Deborah's talk about cell culture basics, let us know if you have any questions and if you need any product and support requests. Okay, and if you participate in this poll, you also stand a chance to win our Momax UV sanitizing box. It also comes with wireless charging and it's worth about Singapore dollars, about $60. So we'll be giving out 4 units of this sanitizing box tomorrow at our lucky draw. So the more you participate, the more it will increase your chance of winning at this lucky draw. Okay, so everyone, I would encourage all of you to participate in this poll. We'll be opening it up for about 5 minutes. So please take some time to go through the poll before our next speaker, David, who will talk about sample management and storage. And in the meantime, if you still have any other questions for Dr. Deborah, she'll still be on the line with us. So please write in our Q&A if you have any direct questions so she can answer you directly. All right, so in this poll, you will see around 6 questions. So please help us to fill in them. All right, we have around 3 minutes left. So for those who have not started on the poll, please kickstart right now. And for those who have completed, thank you so much. You guys can go for a quick coffee or bio break before our next session begins. So just to let you guys know, this is our first time doing this poll at Gibco Galaxy Tour. And after every session, we'll be having this poll. So once you complete all the polls, we'll do a live lucky draw tomorrow. So please also join our session tomorrow as well, where we will cover transfection basics. And of course, at Thermo Fisher, we hope to deliver better presentations and events to you every year. So please let us know if you have any feedback for today's session. And maybe also in the last question, you can let us know, hey, what other topics that you're interested in, or if there's any other products that you are interested in, please let us know. And we can also share any other interesting literatures with you. But if you also log on to our Gibco Galaxy Tour webpage, you can also see our cell culture handbooks and literatures. And our one cell biology portfolio is also all over there. So you can also download some of the literature links over there as well. All right, we have just about 1.5 minutes left. So for those who are still doing the poll, I will urge all of you to quickly wrap up. And don't forget, we'll also be doing another poll after David's session about sample storage later. So you just need to complete 2 polls and you'll double your chances of winning this UV sanitizing box. Alright, just to share, I think some of you might have some audio issues earlier on with WebEx. I think maybe just to reiterate, you guys can actually log out and log in again, or maybe try to use a earpiece or switch to computer audio just to double check your audio settings again. You can click the more options, which is these three dots at the bottom, and go to switch audio, and maybe also use a earpiece so you can better hear our speakers later. If it doesn't work, maybe just log out and log in back to this event page to ensure that you actually can hear our speakers, because this is very important. Okay? All right, we'll just be closing the poll in 20 seconds time. And for those of you who might need to head to the washroom, go for a quick bio break and come back, because our next speaker will start very, very soon. All right, and you do not want to miss that session. All right, I think over to you, Lydia.
All right, thank you, Sonia, and thank you very much, Deborah, for the presentation. I would like now to introduce David Wang, our second speaker for the day. So David is our regional product manager for laboratory plastic essentials, and he will be covering another aspect critical to cell culture success, which is sample storage. Again, if you have a question for our speaker, please send it through the Q&A box. This is indicated by a question mark icon near the bottom of the screen. So now let's give a warm welcome to David. David, over to you.
Thank you. Can you hear me clearly?
Yeah, yes, we can, David.
Thank you. Thank you, Lydia. Yep. So good morning, everyone. I'm David, and today I would like to share some knowledge of how to manage it and prepare our sample storage. Of course, normally we were saying that it was a cryopreservation. Yep. So through this agenda, we will first going through the physics of cryopreservation, following by the typical long-term storage condition, which including the temperature and what equipment we are using. And later on, we'll share some good practice for cryopreservation coming from a lot of resources from research. And then later on is a sample management basic requirement. Finally, I will introduce some useful tools to helping us to manage our sample better. Yeah. So starting from the physics of cryopreservation, I believe some of you have known this background knowledge already, but right now I just want to highlight again of the water. Yeah. So during our cryopreservation, when you put the samples in the buffers in the medias, after we putting them in the refrigerator or ULT, the water will come into crystallize. And when the temperature going down to the -80 to -130 degree, the ice will becoming a cubic crystal, which is very sharp and will damage all our samples, including the DNA, including protein, and also for, of course, the cells. But later on, when the temperature continuing going down to the -130 degree, later the ice will becoming an amorphous ice. So under this situation, the H2O molecule will not be arranged in a regular shape and will becoming a very, very condensed of structure. So under this situation, all the biologic activity will be stopped. So that's why normally we will start our cells line, mammalian cells, tissues under the liquid nitrogen, because it will reduce the biological activity at the amorphous ice phase. In addition to the temperature reduction, so normally we are trying to using different kind of equipment to store different kind of our compound or samples. For example, our protein and genomic materials normally will put in the -80 degree of liquid nitrogen or of the ultra low temperature refrigerator. And for most of the microbiomes, normally will also store at the ultra low temperature refrigerator. However, when we're storing our tissue samples, our animal cell line or plant cell line, normally we will put inside the liquid nitrogen because we want to preventing the bioactivity within the cells. So here comes some suggestion guide of how to put our sample and where to put. For example, under the 4 degree, some of the enzyme, antibody, and which sample is now used for long-term storage, we can put in the 4 degree. However, when we store the compound, normally it will be suggested to put at a -20 degree of the freezer. When we want to store about the DNA, RNA, or bacteria, some biological samples like blood sample from patient or some protein and enzyme, we normally put in the ultra-low temperature freezer to preventing some bioactivity. However, when we're storing our cell line for long-term storage, of course, we will considering the liquid nitrogen. Of course, the vapor phase of liquid nitrogen will be a better option to storing all the samples because it can preventing a lot of damage and the contamination risk. As we mentioned before, the biologic activity is healthy below the -130 degree. So all the stored sample between the -130 to -190, which is the typical temperature of the liquid nitrogen, can desire as a long-term storage. So here comes some example of how we store our protein sample. Typically, we need a buffer with cryoprotectant and additive, or even in the powder form to store the protein samples. So how the cryoprotectant normally we can using the glycerol or ethylene glycol, and the additive we can using additional protease inhibitor, sodium enzyme, or EDTA, DTT, to preventing the protein degradation. Under this kind of the solutions, we can put these protein samples at different temperature. For the short-term storage, normally we can put on the 4 degree of the freezer, and you can keep around 1 month when you adding that additive to preventing the degradation. In addition to the short-term storage, normally we can put the samples under -20 degree for around 1 year. So this solution with the glycerol and ethylene glycol can helping us to protect the proteins under the -20 degree. And normally this kind of the storage can be reused and restoring for many times. In addition to this kind of short-term storage, when we want to store the samples for longer time, we will put it to the -80 or liquid nitrogen, or even to using the dry phase of the protein. So under this situation, we can store this for over years or maybe then decade. However, under this long-term storage situation, we can only restore these samples for one time. We cannot repeating the thawing and freezing steps because it will damage the protein structure. In addition to the protein storage, of course, normally we will store a lot of DNA and RNA samples, like the plasmid, the messenger RNA, or cDNA from our cell samples. So the majority step of the RNA and DNA storage is that we're trying to preventing the degradation. So how can we preventing the degradation? First of all, we need to providing a very clean water, which can providing a DNA and RNA-free environment. The DEPC water is widely used in our storage of the genomic material. However, we must to clean the DEPC before we processing the storage. The additional material is required also for the genomic material storage, like the sodium citrate or trace buffer, which is very helpful for stabilize the genomic materials. And also ethanol and isopropanol is another very good item and solution to helping us to keeping the DNA and RNA very stable. And of course, we must to prepare a multiple single-use aliquot to all the batch. Here is some example of the temperature and timeline that we can store of our samples. For short-term storage, you may have a lot of experience. We can keep them in the 4 degree. However, the sample can only keep for weeks. For the intermediate storage, we can put it on the ultra-low temperature freezer. And normally it can only keep for months of stable. So of course, for long-term storage, we're suggesting to put all the genomic materials under liquid nitrogen for years or for decades. In addition, you can dry the materials and you can keep this dry phase of the genomic materials for over 15 years. Now we're coming to some microbiomes. For bacteria and virus, a lot of people are using that for the genomic analysis or production of some recombinant protein. So first of all, we must using a proper storage media for the better recovery, because we help all the bacteria or virus, when we recover that, they can have a higher viability for our downstream process. So one key point is adding proper cryoprotectant like DMSO, glycerol, or sucrose. In addition to the cryoprotectant, we can also adding some cryopreservant like polysaccharide, protein, or dextran to protect the cell from damaging of the freezing. Normally, we can store the bacteria under the agarose plate. However, it can only keep for several weeks. But if we store at a stable culture, it can keep in for 3 weeks to 1 year. When we want to put in that or store the bacteria or virus for longer term, of course, we need to store at a -20 or -80. The last that the freezing dry. Also, bacteria and virus can also proceed in the freezing dry and keep stored under the -20 or 4 degree for over 15 years. Because without the water molecule, the microbials will keep very stable under the low temperature for several years. Now going to our daily use of the animal cell culture. So most of the cell culture can be stored for many years. So if not identifying, the temperature should be lowering to -130 degree. In that case, it should be liquid nitrogen. So during our freezing step, we need a very, very slow cooling rate. Generally, it was 1 degree per minute. So for different kind of the cooling rate, it may damage the cell and affecting the viability after we store in the cell. Also, the crop protectant agent, such as glycerol or DMSO, is widely used during our cryopreservation. Also, the commercialized freezing media is very helpful for you because it has prepared a very designed ratio of the cryoprotectant compared with the medias and serum. So after we freezing the cell slowly until it reaches the -70 degree, we can transfer it into the liquid nitrogen freezer, which can maintain the temperature below the -130 degree. It is important that we must store all the cell samples on the vapor phase of liquid nitrogen. As we mentioned before, the liquid phase of liquid nitrogen may have some leakage issue, and also it will be a cross-contamination risk when we're storing a sample. In addition to the cross-contamination, some of the explosion will be happen when we restoring the cells. I believe most of you may have the experience of the cryotube will explore after we putting that in the water base. Yeah. So how to preventing this kind of the accident? The first step is that we try to put all the cryotube in the correct position. It was vapor phase of liquid nitrogen. So when we sowing the frozen cells, sowing frozen cells is rapid. We must sowing this rapidly and using a pre-warm growth medium to dilute all the frozen cells, because we need to preventing the DMSO damage after we sowing the cell. So here you can see some experience or some data showing that the cell line, when we're using the serum-free, cell-free medium or the freezing medium with FBS, actually the recovery rate is quite near similar. So for both of the material, it should be useful for your freezing cells. Of course, the commercialized one can helping you to protect cell better. So after the basics of some of the experience, now I want to share some good practice for our cryopreservation. Actually, it should be the major part of our today's section. The first is a reduction rate of temperature. Here you can see a physical record of the samples when we put them inside the freezers after the temperature going down to the 0 degree. Later on, there will be a lag phase that will heading the evolution up to freezing. And later on, the temperature will continue going down. So if we want to keeping the freezing rate as a -1 degree per minute, we must using some supportive materials to helping us to achieve this goal. For example, the ideal cooling rate is -1 per minute by using the isopropanol with some cooling container. It can reach nearly -1 degree per minute to protect cell from damage of the fast rate of the cryopreservation. So how can we must using such kind of a temperature control method to protecting our cells? It was coming from the technical of the freezing. when we have a fast cooling rate, there are more water being into the crystal in the cells. And it will be a less osmotic imbalance between the cells and the media, and less dehydration of the cells. So as you can see, when the water becoming the ice and the cubic ice, it may damage the cells because it have more ice inside the cells. However, when we're slowing down the cooling rate, there will be a less intracellular ice compared with the previous one, the fast cooling rate. However, there will be more osmotic imbalance between the cells and the medians, and more dehydration sometimes will also damage the cell because we add additional DMSO to protecting the cell. So the balance between the fast cooling rate and balance of cooling rate, it should be considered by ourselves. Right now, I'm showing you some technical guidance from ATCC. As you can see, there are suggested cooling rate for different kinds of cells. For example, the stem cell should using the -1 degree to -10 degree per minute to reaching the survival rate to highest. So some example here, for yeast, we must using the 10 degree per minute as our cooling rate. For human sperm, it should be going to 10 to -100 degree per minute. And the red blood cell is a very, very special case. It should be cooling as fast as possible to 200 to 1000 degree per minute. However, when we go into the PBNC and most of the regular mammalian cell line, it going back to the -1 degree per minute. So depending on the sample and the cell line you are using, we must using different kind of cooling rate to make the cell have a best recovery rate. So if you have any experience on why I store my sample with a proper protocol in the laboratory, in our lab, but the cell recovery rate is not good, the major reason should be coming from the cell cooling rate. You should be determining that by a lot of resource and some reference. In addition to the cooling rate, we can select proper consumables for different sample type. As you can see, we can using the cryotube for most of our cell stock and tissue or biological fluid. However, if we want to store the DNA, RNA, or some protein compound, I know most of you will using the open top microcentrifuge tubes or the small vials that just for short-term storage. So of course, because the volume is too big for them when we're using cryotubes, so sometimes we're using the alternative consumables for that. In addition to this kind of the cryo vials, we can also using the storage plates as an alternative material. For example, a high throughput genomic analysis lab will using the 96-well storage plate to store all the samples and the genomic DNA. After they filling all the different clone of the genomic DNA, they can using the sealing tab to protecting the samples and then store in the proper temperature. In addition to this kind of the manual storage process, actually we can also selecting some of the pre-made barcode system for easier tracking of all the samples. Like the universal tubes, it just looks like a general cryo tubes. However, it was barcoded at the bottom of the tube. When we stock all our cells inside the universal tube, in addition to writing the information at the site, we can also reading the 2D barcode to recognize the sample ID. So the sample ID is Unicode, and then we can identify all the information within these tubes. So when we're going to the high throughput or the smaller volume of the storage, like the genomic material and protein, We can using the 2D storage tubes with a 96-12 format, just like the storage plate. So it can dramatically reduce the space we will use in the freezers or liquid nitrogen. Also, it will helping us to more trace and finding out which of the sample is what we are looking for. So the traceability is best under the universal tube and 2D cryo tube. However, normally we were using a cryo vial as our starting of the cryopreservation step. So going to the reducing the risk of liquid nitrogen leakage. I believe most of you have facing some challenge when the liquid nitrogen will leak inside the cryo tube. So there are some key points that we can use to helping us preventing such kind of the risk. The first one is using the proper consumables. It was the major for the sample protection. You can using the leak-proof cryo tube without the O-ring. Why now we are trying to highlighting the O-ring? Because under the analysis from the expert, it was a biobank global guidance. The O-ring tubes normally have a higher risk of liquid nitrogen leakage, while the cryo tube without an O-ring have a less risk of a liquid nitrogen leakage. So secure the sealing tape or insert. It was also important for us to confirm all the insert and sealing tape is properly attached to our sample tubes. In addition, tube can be also placed in the sealed unbreakable plastic container to preventing the additional risk for the sample falling down or miss of the sample in the liquid nitrogen tank. In addition, store this sample by safety protocol. It was what we call the best practice. Just like always, we need to put our vials in the vapor phase of liquid nitrogen. And sometimes we can specialize the CryoFlex tubing. It was a protection tube that can seal the tube itself. So preventing all the liquid nitrogen leakage issue. In addition, of course, we cannot overfill the cryo vials. For example, if we are using the 1.8 ml of cryo tube, normally we can only fill in less than 1.5 ml, just because when we're freezing the cells, the liquid volume will increase. And finally, we must wear the personal protective equipment. This was helping us to self-protection, like face shield and gloves and lab coats, to preventing all the liquid nitrogen leakage or cryo tube explosion issue when we sewing the cells. Now I'm showing you some sample management example. Here is a general workflow of our storage. First of all, we will collecting the sample from cell culture, from tissue, or from some other resource like other laboratory. After we processing this, like we extract the isolation, or we doing the cell culturing, and later on we suspend this cell again. Now we're going to the centralized storage, aliquot them and sealing by the sealing tape or the closures. And then we are using the label both by the cryo markers or some 1D barcode or 2D barcodes. And then later on, we will register this labeled cryo tube and trying to tracking of all the sample information. From this part, we can link this data to such kind of cell analysis, genomic research, or protein antibody research. After this, we store the cells, and it will becoming a circle. After the storation, we are going back to check all the sample, what kind of the sample we have stored, and what of the application we have did for this kind of the stored sample. Also, going back to aliquot, when we want to running the second part of our analysis and process, we will resewing these samples again, and then go through this kind of the centralized storage circle. So during this period, what is our challenge here? I'm not sure if you have ever using such kind of a ULT. From my experience, more than 70% of the lab users will facing such kind of challenge. So it's not only as good as your sample quality, integrity, and history for this kind of a ULT. What will make the challenge of this ULT? The first one is uniformity. So at the upper side and the lower side, there will be a variance in temperature just because you put a lot of things in different layers. And there are some ice was blocking the airflow of the ULT. So multi-layer location will affecting the temperature and will affecting your sample storage. In addition, the stability is also be affected because variance of the temperature at one point in the chamber. So usually measuring the center, we will measuring the center temperature of the ULT. However, when you're facing such kind of the challenge like a lot of ice clogging, the temperature detection will be not so even in different points. So how, if we listing down all the sample challenge, the sample is not properly identified because we're missing some of the information where is my sample is. So inability to locate this sample is also same as the previous issue. Then quality and history is unknown because you may miss a lot of sample history. And lack of accurate and accessible inventory, just because you miss a lot of sample within this ULT, you don't know how many of samples you are still keeping. And the final one, there is no linkage between the raw data and the samples. So all the challenge here, we can converting to the question to us. And by using this question, it can helping us to better manage of our samples. The first, where do I store this tube? So it was a location. The second, what is the status of each cryo tube? It was related to our storage situation and our sample data. The third one, how do I search request or even approval for the shipping of the samples? It was related to the management of all your samples. And maybe there are some cooperative person that will want to have some sample sharing protocol with you. The fourth one, how do I manage the sample privacy and consent? So this is some requirement from the biobank or some big lab. They need some security and privacy of all the samples. The latest one, how can I supporting and work with the external partner as end customer? For example, if you have some cell line, they will sharing to other laboratory. It's very important to have a very good tracking method to this kind of sharing. So streamlining the requirement information for the sample storage. The first, position. The second one is the sample data. So what's the type, what is our labeling, and how is the experiment data. Additional information will helping us to more clarify all the samples, like the sample resource and what we have did for this kind of the cell line. In addition, the assistant system is used for the alarm or GLP laboratories. So integrating all this information, we can see that starting from the instrument, we have a ULT, we have a liquid nitrogen tank with our labeled cryotube inside or labeled plate inside. And this labeling will link to all the data like the sample type, sample resource, and other experiment data. So as you can see, the most important part is labeling. Here is some guidance also coming from the expert. So each specimen should be receive a label with a strong and permanent adhesive that can be withstand under the cryogenic temperature and survive in all planning process conditions. Like if you want to processing or store this over than 10 years, can the cryo marker keeping the same clear after the 10 years? Or if you want to shipping all the samples to different laboratory, can the cryo markers keeps clear after the transportation? So the strong and permanent label is our key point for sample management. So following by this topic, we'll sharing you some supporting tool to how to helping us better manage of our sample. So we have highlighting the labeling. Here is some helpful material to helping us have a better labeling. As you can see, the standard cryotube, we have a writing part here. So normally we will using the crowd marker to recognize a sample information at the labeling part. However, it will be challenged if we putting this labeling for over the years. And in addition, for your lab, there are several people will store their samples in the same space, and the labeling will be different between each person. So after someone is leaving the laboratory, we don't know what exactly inside of the tube because everyone has their own labeling. So following the manual labeling, the upgrade version is a linear barcode crowd valves, and it was widely used in the hospital sample storage because they need to very carefully handling all the patient samples. So linear barcode for visual identical is a widely used version, and this was available from 1 mil to 5 mil coming from NANC brand. In addition to the linear barcode crowd valves, there are 2D barcode tube system as well. So this kind of 2D barcode system is helping us to processing the sample management faster than the 1D barcode. As you can see, the barcode was located at the bottom of the crowd tube. So we can easily to recognize and reading all the tube information within 10 seconds. Compared to the 1D barcode, we must read each tube one by one. So the time will save a lot when we're using the 2D barcode system. Combining with the rack format of reader, it also including different kind of volume to fasten our workflow of the crowd preservation identity and the management. So once our sample is going upgrade or expansion our crowd preservation space, there are some options can be considering. The first one's how we can using the linear barcode crowd tube, and the second one, we can just transferring to all this crowd tube to 2D barcode system. In addition to this barcode system, we can also using some helpful tool to when we're handling the crowd tube. So it was coming from the crowd tube holder and decapper system. So the holder can helping us to fixing the crowd tube with the anti-rotation function, so easier for us to handle more than 10 crowd tubes. In addition to the manual process, we can also using the manual decapper or automation decapper. Of course, this decapper will combine with the brand of the crowd tube you are using. So do remember, we have the option for the high throughput handling of the crowd tube. And we will helping us to saving more than 50% of handling time when we have a lot of crowd tube handling at one time. So finally, going to the sample management. Of course, we will have some sample management method when we processing every of the crowd preservation. For example, we may using the Excel file to identify all the crowd valves, or we will using the paper to recognize which box and which location and where is the crowd tube we put inside. So in addition to this kind of a simple sample management, we can also buy in some sample management software from other resources. For example, here is a very good example of sample management. It including the sample position in the which shelf, which rack, and which box. And also within one box, as you can see, there are different kind of sample type. When we click one of them, it can showing the additional information like where is the ID. The ID coming from the barcode or coming from our Unicode ID we designed for these tubes. In addition, there are a lot of information we'll list it in here, like the volume, like the resource, and which group they're gathering from. So this kind of the sample management software major use in the hospital or the biobank. However, for each lab, we can still using similar idea of this sample management software to recognize the position, recognize the sample ID, even we're using the crowd marker to labeling the crowd tube by ourselves. And also the sample type and sample information will be added and linked to the crowd tube itself. So most of all, import and removing is an important thing for the sample management. So even from the Excel file, we can adding some function by macro to have a deletion and adding function when we import or export our samples. Of course, if you buying the management software, it will be very easy for us to using this kind of a function. So finally, it was a storage setting process. Something we need to considering before we set up the storage condition and storage space. First is the sample information. What is our type? What is our sample volume? And how many is our sample number? Later on, depending on this kind of information, we can selecting correct consumables for like the coil tubes, like the how is a rack design, the box design, and also what sample management system we were using. The manual writing, the 1D barcode, 2D barcode, or even the RFID coil tubes. And later on, we can using the proper instrument to storing our samples. So select the correct equipment from our sample types because it depending on the temperature. Select proper rack for sample volume. And finally, define the equipment quantity depending on our sample number. So later on, we can looking at the infrastructure design. Of course, right now, I believe most of our laboratory have already designed the infrastructure. So we must, at last, we need to selecting the correct equipment for storing our samples. So after this process, the sample information need to link to our labeling, and then sample management tool like the paper recording, Excel file, or management software, or even for the link system, will link all the equipment together. So the purpose for this storage setting process is trying to transferring the ULT from this one to the more organized one. Yeah. So right now is the final conclusion for today's presentation. So all the sample should be stored under the correct protocol and the environment. So today we have a basic look of the cryopreservation, and then we looking at the cryopreservation method for different kind of sample. Store the sample under correct temperature, using proper cooling rate for different sample type, and protect ourselves from damage of the liquid nitrogen explosion. The final one is sample management. So when we expand our capacity of the cryopreservation, we can using different kind of the barcode system tubes, and using the decaper helping us to faster proceeding our opening and closing of the closures. And do remember, link all the management information to our permanent label will helping us to better management all our samples. So here is my presentation for today, and thank you for your attendee. Here now we can go into our Q&A section. You can raise all your Q&A question and while click the Q&A option. Thank you.
Hi, Lydia, we cannot hear you.
Hi, sorry. Thank you again, David, for the presentation. So we're now ready to take your questions. Again, if you have a question for the speaker, please feel free to send it through the Q&A box. Right now, I think a number of questions have come up. Most of it have already been answered by our panelists. Just one question from Hui Ling. Hi, Hui Ling again. I usually store 1 million cells per ml, and I'm wondering whether is it possible to freeze down higher concentration of cells. Is the cell density of the frozen cells a major concern? Hi, David. Can you hear?
Let me unmute myself. Okay. So for the cell density, yeah, normally from 10 times 6 up to 10 times 7, it should be a proper storage concentration for the cells. So 1 million should be suitable for your cell. However, it depending on your cell type, because for most of the cell lines, right, it can recover under this kind of the concentration. But for those cell line with, they require some of the contact for each cell, like the neuroblastoma, you may using the higher concentration of the cell density. So it really depending on the cell line. Like for HUVEC, for the HEC or HeLa cell, the number is enough. Yeah. So 10 times 6 to 10 times 7 is a proper cell line storage condition. Yeah. Hope this answered your question.
All right, thank you, David. Another question that came through, can we also use a barcoded cryotube system in a small lab?
Yeah, okay. So actually it was okay for all lab using the barcode system, just depending on the budget you have. We have some experience with helping our users to set up a very small bell bank. They just using the 2D barcode for small quantities, and then using the one single tube barcode reader to recognize all the samples. However, it was very helpful for them because they are under the upgrading schedule, so they can upgrade the system without any pain point. For example, if you're using the manual storage at this moment, later on, you want to transfer into a 2D system, all the information you need to recognize again. So it was okay for all the users to using the 2D barcode system, even with a small amount or small quantity of the cryotubes.
All right, so that's all the questions that we have. Please continue to send your questions through, and also you can put your questions in the poll later on when it opens. So now I'm passing it over to Sonia.
All right. Hi everyone. Good morning or good afternoon to our
A very good morning once again to everyone, and welcome to the second day of our Gibco Galaxy education series. If you have joined us yesterday, welcome back. Today, I'm excited to welcome our cell biology technical sales specialist, Dr. Zhou Yu, who will cover the various factors to consider when planning a transfection experiment. Sorry. Before I hand over the mic to Dr. Zhou, I would, for the benefit of those of you who are joining us for the first time today, like to go through a few housekeeping items. First, again, today's webinar will be available on demand after the live session and is available and is accessible through the same Thermo Fisher link that you have received in your email. Next, if you have a question for our speaker, please feel free to send it through the Q&A box at the bottom of the screen. Our panelists are on standby to take these questions, and we will also address them verbally at the end of the session. And last, we'd like to encourage you to share any questions and feedback you have for us at a poll that we will open at the end of the presentation. A lucky draw will be done at the end of the session today for everyone who participated in our poll. I'll now be passing the mic over to Dr. Zhou. Let's welcome Zhou Yu on the screen. Zhou Yu, over to you.
Thank you, Lydia. So good morning, ladies and gentlemen. Welcome to join our annual Gibco Galaxy Tour. My name is Zhou Yu. I'm the product manager for cell biology and synthetic biology, taking care of Singapore and other Southeast Asian countries. I'm very honored today to be here, share a little bit about transfection basics. I sincerely hope that after this presentation, you'll have a better understanding of transfection and improve your transfection efficiency in your research work. So here's the agenda for today's presentation. So first of all, I'm going to share the definition of transfection and the common delivery methods often used. Next, I'll focus on lipid transfection in electroporation, followed by the comparison of stable and transient transfection. Lastly, I'll share some tips of how you can optimize and improve your transfection work. There will be a Q&A session after this presentation, but if you have any questions during my presentation, as mentioned earlier, you can share your questions in the Q&A section at the bottom of your WebEx window. My colleagues will assist you with your questions. So without further ado, let's start our presentation today. So first of all, what is transfection? In biology, there are different scientific terms describing different processes, and some of them are quite similar and confusing. For example, in cell culture, we heard transfection, transformations, and transductions. Today, let's get all these terms sorted out once and for all. First of all, transfection. Transfection is the process of artificially introducing external DNA, RNA, or protein into eukaryotic cells. There's a similar term called transformations, which usually describes the process of delivering plasmid DNA into a prokaryotic cells such as E. coli. The last term, which is very similar as well, called transduction. It actually describes the process that exogenous DNA or RNA is transferred into the eukaryotic cells or prokaryotic cells through viral infection. So transduction is also often referred as infections. So why do we need so many terms while all of them describes a very similar process, which is delivery DNA, RNA, or proteins inside the cells? So for example, transfection and transformations are very similar. Why do we need two different terms? The reason is, in animal biology, the word transformation has already been used describing another process, which is a normal cell becomes a cancer cell. So to avoid mixing up, we created a new term called transfection, just for eukaryotic cells. Similarly, transduction is in fact the same process as infection, but now we usually refer the naturally occurred viral infection as infection, but the artificial infection of virus for the purpose of delivering DNA or RNA we call transductions. So let's have a very quick recap. If you put plasmid into a bacteria, it's transformation. If virus is used as a vector, it's transduction. Otherwise, it's transfection. All right. I hope everyone is now very clear with the terms. Next, I will take you further about transfections. So why do we need transfection, right? When we put something into the cells, we definitely expect something happen, right? So if we deliver a gene inside the cell, we actually increase the copy number of that particular gene so that the gene is so-called overexpressed. So by analyzing the phenotype of these cells, we can link the gene with a phenotype. Or we can do it the other way around. By introducing siRNA or CRISPR-Cas9 into the cell, we can suppress or totally abolish the expression of that particular gene. Then we observe the phenotype change. Either way, it really helps us to understand the function of that certain gene. We can also deliver genome editing tools such as CRISPR-Cas9 or TAL into cells to do a more precise editing of certain genes. For example, we can create a particular gene deficiency which really mimics the specific genetic disease, with which we can test our new drugs. As we know, some genes are coding for proteins, right? So by overexpressing those genes, we actually expect more protein expression. So transfection is also very heavily used in protein production, such as antibody production or vaccine development. Additionally, in iPSC-induced pluripotent stem cell reprogramming, where we need to express 4 different genes simultaneously to make somatic cells into iPSCs, and this reprogramming process can also be done by transfection. Next, let me share with you some common transfection methods. There are many different ways to do transfections. Basically, the methods can be categorized into 3 groups: chemical ways, physical ways, and viral ways. As mentioned earlier, whenever a virus is involved, we call it transduction, which I will not talk about today. For chemical ways of transfection, very commonly used is lipid-mediated transfection. I can say about 80% of the transfection reagents in the market are lipid-based. People also use polymers or occasionally inorganic components such as calcium phosphate. For physical ways of transfection, electroporation is very popular. Optoperforation, also known as optical transfection, is not that widely used. Microinjection is an old school method. You usually see this in sci-fi movies 20 years ago, but it is still used in studies dealing with relatively large cells, such as zebrafish fertilized egg. So today, I'm going to focus on the lipid-based transfection and electroporations. So the idea of lipid-based transfection is to pack the DNA, RNA, or protein into a liposome complex, which is positively charged. Then the complex is delivered into the cell through a process called endocytosis. I'm going to talk about a little bit more why the liposome needs to be positively charged later, but overall, the lipid media transfection has the advantages of being very high efficiency and works for a wide range of cell types. It can really deliver molecules from almost any size, from as small as 10 nucleotides oligos to above 600 kilo base pair DNA. It can also be used in both in vivo and in vitro. So how electroporation works is even simpler. So basically, we treat the cells with controlled electricity pulse so that the membrane of the cells has a temporarily leaky so that the DNA, RNA, or proteins can get inside. The beauty of electroporation is it works very well in all cell types, and including those lipid-mediated transfection doesn't work very well. And the transfection efficiency and the cell viability can be easily tuned by adjusting the voltage, duration, and frequency of the pulse. Let me talk a bit about lipid transfection. This illustration actually nicely shows how lipid transfection works. Remember in my earlier slides, I said the liposome needs to be positively charged. Why? Very simple. Because the DNA, RNA, or protein, which we call the payloads, are all negatively charged, right? And unfortunately, the surface of the cell is also negatively charged. Basic laws of physics, they repel each other, right? Without positively charged liposome to wrap around those payloads, you just can't even get them near the cells. So first step is to combine the liposome and the payloads. For example, this DNA into the DNA liposome complex, also known as a lipoplex. Once you have your positively charged lipoplex, or at least neutral charged lipoplex, it is then taken up by the cell through endocytosis, right? Then it moves further into the nucleus so that it can be transcribed and translated. It might sound easy and straightforward, but the key issue for a successful transfection is that the timing when the DNA is actually released. If DNA is kept inside the lipoplex for too long, it becomes a lysosome and your DNA is degraded. So for RNA, the journey is shorter. It can be released in the cytosol where it could be translated. No need to be inside the nucleus. So as you can see, transfection is as simple as that. But if you are given a transfection reagents and a DNA, where to start? For example, I give you our flagship transfection reagents, our lipofectomy 3000, right? This reagent is very good, no doubt about it. It has the highest transfection efficiency and works for widest range of cell types, and the cells has improved viability. What will be the first thing you need to do? My suggestion is you do optimization first. Very important. Because there are so many factors that can really affect your transfection efficiency, optimization is very critical. To optimize what, right? First of all, the ratio of your payload versus transfection reagents. Why it is important? Let me give you some flashback. Let me go back 2 slides. When we look at this illustration, remember I shared with you that the DNA, RNA, proteins are negative charged, right? The liposome is positive charged. So we really need the lipoplex to be positively charged. So we really need to adjust the ratio of these two so that the net charge of this complex will be still positive. So let me get back to the slides again. So the amount of the ratio of the payload and transfection reagents is very important, as well as the amount of lipoplex can also be optimized, right? The more lipoplex, the higher the chance the cell can take it up, but too much is also a waste, and also it might be toxic to the cells. So it is highly suggested that you try different ratio and amount of lipoplex to get the most optimized setting for your cells. Of course, there are many other factors that will affect the transfection reagents, which I'll share slightly later. By the way, it is also suggested that to use a GFP expression plasmid so that you can quickly quantify the results. For example, on the right side of the slides, we have images of different cells after transfection. By quantifying the green signal, we can have a very quick understanding of how the transfection efficiency is. So in these slides, different cell types are actually transfected with GFP expression plasmid. And from the percentage of the GFP positive cells, you can easily tell which transfection reagents works better for what types of cell. It is always suggested to have a control for your transfection work. For example, you should have a positive controls with an easy to quantify reporter such as GFP, and also a cell line which works before, which you know that it will definitely work. So that if the experiment works on the positive controls, you know at least your protocol has no problem. Negative controls is also very important, especially in overexpression and knockdown or knockout experiment. They really helped confirm that the phenotype change you observed after transfection is really due to the delivery of your payload into the cell, but not because of any other components you used in transfection. So additionally, it is also recommended to transfect your cells at their best condition. If your cells are not healthy, you won't be able to have high efficiency transfection, and what's more, the post-transfection cell viability will be low. So as shown in these slides, right, if you transfect healthy cells, you'll have better transfection efficiency compared if you do the same thing to an unhealthy cell population. Let me quickly summarize the key factors that can really influence the lipid transfection, right? These factors have most impact are the cell type, right? You have to really understand what cell type you are going to transfect, right? And also the quality of the cells. The quality of the cells includes the cell passage number. The reason why we're interested in the cell passage number is because most of the cells will go senescence with the increased passage number. And also, we have to make sure that the cell is not contaminated with any virus, bacteria, or mycoplasma, right? And we also have to make sure that the media is clean. And also, based on the type of cell and also the payloads you are going to deliver, the type of reagents is also important, right? And also the ratio of the lipid to the payloads, as I mentioned earlier, right? And also you have to store the reagent in a proper manner, right? So for example, some transfection reagents need to be stored in -20, right? While some of the reagents can be stored in 4 degrees. But either way, you have to store them properly so that the transfection reagents will work, right? So there are definitely other factors which might affect the transfection efficiency, but not as important as the factors I mentioned just now. So next, let me share a little bit more about electroporation. So electroporation actually uses electricity pulse to create a temporary pulse on the cell membrane, which means we poke holes on the surface. And additionally, as the electrical potential across the cell membrane simultaneously rises. So if you look at here, so if we apply electrical potentials at two sides of the cell, for example, positive on the left, negative on the right, so you'll be able to see the electrical potential builds up across the membrane, right? Negative on the left, positive on the right. So once the electrical potential builds up, there'll be holes, pores happens on the surface of the cell membrane. And remember, the payloads, DNA, RNA, or protein, is also charged particles, right? So it'll be quickly moved into the cell, right? Just like what we do in electrophoresis. So electroporation works very fast, first of all, and it also works quite well on cells which is difficult to transfect using lipid transfection reagents. However, electroporation usually need a special conductive buffer to make sure that the effective transfection and low toxicity. Okay, I'd really like to take this opportunity to introduce our electroporation instruments, the neon transfection system. Neon works very well transfecting extremely difficult to transfect cells, such as immune cells and suspension cells. The reason I want to highlight this neon system is because it's a very unique electroporation instrument. First of all, it has very good results, comparable, if not better than other instruments, but it's a lot more cost effective. Unlike other instruments, it is customizable with pre-programmed optimization protocols so that you can ensure the best parameters for your cell type and experiment. As a result, it's a lot gentler than other instruments, allowing for improved cell viability. Neon also allows for a wide range in the volume of cells, right? You can really transfecting. It's very easy to work with the Neon system, right? Because you only need one single universal buffer. Unlike other instruments, there are different buffers for different cell types. And at the bottom of this slide, I listed 3 very difficult to transfect cells: astrocytes, Jurkat cells, which is a T lymphocyte line, and SKNMC, which is a neuroblastoma cell lines. All of these cells are very difficult to transfect using lipid-based transfection reagents, but as shown here, we have a very nice results using our Neon system. So the unique part of Neon transfection system is its proprietary pipette tip chamber, right? Unlike other commonly available cuvette chambers, our pipette tip chamber generates a much more uniform electrical field, which really allows a better maintenance for physiological conditions, which result in a very high efficiency and cell viability. The workflow using our Neon system is super simple. Once you harvest and count your cell, right, you resuspend the cells in the desired concentration. You aspirate the cells into the pipette tip, like a normal pipette tip. Put it on the reaction chamber, press the button, then the electroporation is done. Then all you need to do is transfer the cells into the pre-prepared culture media. Simple as that. Compared with conventional cuvette system, you really save the steps which you need to firstly transfer your cells in the cuvette, move the cuvette into the electroporator, zap it. Then you still need to take the cuvette out from the electroporator. Then you still have to transfer the cells into the culture vessel. Our Neon system not only saves your time, but most importantly, minimize the chance of contamination. So for electroporation, the most important factors for successful transfection is also the cell type You really have to understand what cell type you are working on, the quality of the cells, and also the density of the cells. As the payloads are delivered into the cells through the pores, like I mentioned, by the electrical potential, you really don't want anything else getting inside the cells unintentionally. So that it is recommended to wash the cells thoroughly, right, before electroporation. Of course, the payload, recovery media, etc., also plays an important role. So far, we have tested over 140 different cell lines in our NEO system, and all protocols and corresponding settings can be found in our database, free to download, and we allow customized protocols as well. So customers can really fine-tune, optimize the settings so that it works best for your cell type. We also have optimization program. So in this program, the system will automatically generating 24 different settings. So customer can do a high throughput testing using a 24-well plates, in which each plate corresponds to one setting, so that customer can identify the best settings in one single experiment. Next, I'd like to talk a little bit about the stable and transient transfection. We often heard the terms transient or stable transfection, but in fact, either transient or stable has nothing to do with transfection process. The way you do transfection is exactly the same. The only difference is whether you do selections. Okay, let me elaborate a little bit more. So usually the concentration of transfected DNA or RNA or proteins in the cells reaches the peak within the first 3 days post-transfection. So for example, if you're using GFP pathway, you will notice the highest percentage of green signal within 3 days. However, as most of the transfected DNA is not really integrated into the cell genome, as continued culture of the cells, the DNA will eventually be diluted as the cell divides. Additionally, we notice some cells choose very high expression of GFP at the first 3 days. These cells, unfortunately, will probably die out due to the toxicity of overexpression of GFP. So eventually, if you continuously culture your cells, your cell line will gradually lose the GFP signal over time. So the purpose of getting a stable transfection is actually to select those tiny fraction of cells with the transfected DNA integrated in their genome. Then how do we do that? First of all, you need to have a plasmid, right, with antibiotic selection genes for the transfection, so that only cells with that selection gene can survive in the presence of antibiotics. So post-transfection, the cells are continuously exposed to antibiotics so that the cells without a selection gene or with diluted selection gene will eventually die out, left only the cells with selection gene integrated in their genome, right? However, as the integration occurs randomly, and the copy numbers and the location it is integrated is also different. So at this stage, right, we actually call the cells a stable pool cell lines, which means they're a mixture of different genotypes. In order to have isogenic cell population, which really requires in some applications, we need to further select the cells through a process called a single cell clone selection, right? So basically, you seed your cells as single cells, then the single cells generate different clones. Then with the help of sequencing, we'll be able to obtain an isogenic cell population. So this table below really summarizes the major differences of transient expression, stable pool, and isogenic stable cell line. So usually a transient expression is used when we look at the short-term effect of expression change. Also, in protein expression, transient expression also helps to get high protein yield in a very short time. Stable pool is usually used to evaluate the gene expression change over a long period of time, but without the need of having isogenic populations. So the applications where we need isogenic stable cell line is for large-scale protein expression, as we really need the best cells of the highest yield and stable performance. It is also important to have isogenic cell lines for applications like disease modeling, because only the precise genotype can really represent the corresponding disease. So much we have talked about transfection. Next, I would like to share with you some tips which can help you in your transfection work. Basically, you need to look out for the following aspects. First, the cell type, right? Are the cells you are working on considered easy or hard to transfect? The payload that you are going to deliver. And according to the payload and the cell type, right, you have to choose the best transfection methods or reagents. And next, most importantly, you need to do optimizations before you start your actual work. And because there are so many factors that could really affect your final results, in order to minimize the confounding factors during the optimization process, you have to make sure that your cells is in a healthy condition and at the right confluency. The payload you are using is also very important, because when you prepare your DNA, RNA, or protein, you have to make sure that it's pure enough and is free from endotoxin. Because if you introduce endotoxin into the cell, you will eventually kill the cell. So a quickly recap, transfection is the process of artificially introducing DNA, RNA, or proteins into cells. Transfection is very useful for downstream applications such as gene editing, gene therapy, protein expression, stem cell research, and immune therapy. Here's a quick comparison of electrophorations, lipid transfection, and viral transduction. For workhorse cells, right? Workhorse cells actually means those easy to transfect cells. All of them works very well. However, electrophoration and viral transduction works slightly better than lipid-mediated transfection in those hard to transfect cells. Electrophoration might have a lower performance in terms of cell viability, scalability, and also not that cost effective compared with the other two. However, a viral transduction has its own disadvantage because, for example, there are biosafety limitation, right? So you really need a special equipment or special room for viral works. And the workflow is not very simple. So basically, there are pros and cons in all these three different methods, but the most important thing for customer is to choose the best for their own applications. You can start with simple and cheap lipid-based transfection first. If it really doesn't work out, then you can move on to electroporation or viral transduction. Lastly, I'd really like to share this nice transfection decision guide table. It is very informative and it's very easy to use. Basically, as long as you can confirm your cell type and the payload, you will be able to find the most suitable system and corresponding products. For example, if you want to edit your, for example, ESC using CRISPR-Cas9, ESC is a stem cell. You will find that CRISPR is here, right? CRISPR-Cas9 is here. Then you cross-check for stem cell, right? CRISPR-Cas9 stem cell, CRISPR-Cas9 stem cell. So you just follow the line, then you will see it is recommended to use neotransfection system or a lipofectomy stem reagents, right? It's very easy to use. So for more information of transfection and our transfection products, please do visit our website at thermofisher.com/transfection. You will find a lot of useful information such as basic knowledge, guides and protocols for different products, online tools such as transfection protocol, calculator, and so on. You can also reach us through email if you have doubts or any technical inquiries. Finally, this is my last slide. Thermo Fisher Scientific has a long history of providing quality products to our customers. We have several types of Gibco cell culture media, from the basics like DMEM to the advanced media types. We even provide the options of making your own custom media according to your specifications. We also have FBS from different regions around the globe and with different treatments such as heat inactivation or dialysis. To complete your desired cell culture media and FBS, we provide an extensive selection of cell culture vessels. Some of these vessels are used for adherent cells, while others, like Saphira plates, are used to grow suspension cells or 3D cultures. On top of these, we have a variety of transfection reagents available depending on the cell type and your applications. Thank you very much for your attention. I think I'll pass the ball back to the host. If you have any questions, yeah, please unmute yourself and ask questions.
Thank you, Zoe, for the presentation. Hi, thank you, Zoe, for the presentation. We're now ready to take your questions. If you have a question for our speaker, please feel free to send it through the Q&A box indicated by a question mark icon near the bottom of the screen. Sorry, there are a few questions already online. Let me just go through them and okay. One question from Wu Tao Tuan. Which products can be substituted for extreme gene HPDNA transfection reagent? I intend to use with HEC293 and HEC293 HFSHR cells.
Okay, so this question is really related to protein expression. So just for information that our XP system actually is a bundle, right? So all the components in that XP system has been optimized while works together. So the system works best if you use the same components in that kit. So we are not really recommended to really replace any of these components with other components. So in your case, it's best to use our original XP lipofectamine for the 293 transfections. If you really want to try our, other transfection reagents, unfortunately, we don't have any data to support the efficiency, right? I hope it answered your questions.
All right, thank you, Zoe. Next question from Vivid. How many times should a transfected cell be cultured?
Well, it really depends on the lifespan of the cells. So usually, okay, so if you are talking about normal cell culture, not the protein expression, usually, first of all, you only need to do one transfection, right? Most of the time, you only need to do one transfection, right? So after transfection, of course, you need to revive the cells by putting the cells back to their normal culture media, and of course, followed by selection steps if needed. So it's really difficult to see how many times you can really culture the cells. It really depends on like how long that your cells can be cultured. Yeah, that's. I hope it really answered the question.
All right, thank you, Zoe. Next question from Winnie. If the DNA we use produced from E. coli is the source, which is the source of endotoxin, do we need to do further steps to remove endotoxin before transfection?
Okay, so if you already observed suboptimal performance of the transfection, So if you use that this unpurified DNA, right, to transfect your cells, and it doesn't work very well, and you really suspect that it is because of the endotoxin inside, it is definitely suggest that you do an extra step to remove that endotoxin. And we do have like the plasmid DNA purification kit that you can choose to do that. I think Amazon just replied you with the link. Yeah.
All right. Sorry, it's a lot of questions coming through, so I'm going through them. All right. A question from Sophia. Does seeding cells 24 hours before transfection make any difference compared to doing it at the moment of transfection?
Okay, so actually this is considered not a very impact factor, right? So basically the cell confluency is most important, right? So actually the cell confluence actually affects the cell cycle, right? So it depends on how confluent the cell is, the cells actually in a different cell cycles, right? So the best cell cycle for transfection is that the cells is actively dividing, right? So if your cell is too confluenced or very low confluency, right? The cells are not really actively dividing, so that the transfection efficiency will not be that good, right? So doesn't matter if you seed 24 hours before or if you just transfect your cells during the culture. As long as you can make sure that the cells is actively dividing, you will have slightly better transfection efficiency. Yeah.
All right.
Yeah.
Thank you, Zoe, again. Next, 3 questions. First one from Sanger. Do you have any suggestion for transfection in human endothelial cell lines and making stable cells?
Okay, so I think the first thing you can try is our lipofectamine 3000 reagents, right? Because this is the most versatile reagents available, right? And making the stable cell lines, as I mentioned, has nothing to do with the transfection process, right? So you really need to plan your experiment and also make sure that you have the right plasmid with the right selection genes so that you can do a proper selection. But of course, you have to make sure that your endothelial cell lines is somehow immortal, or at least it can really be cultured to be kept in the culture for long enough before you can do the selections. Yeah. Okay.
All
I
right.
hope they answer your questions. Yeah.
Okay, the next question from Rich. Does antibiotics in culture medium decrease transfection efficiency?
Slightly, but as I mentioned, the presence of antibody is not really the key impacting factors for transfection efficiency. So there are some reports indicates that one of the reason why antibiotics can really affect the transfection efficiency is because that the antibiotics is charged, right? It can disrupt the lipoplex formation, right? So second of all, actually, it's not about transfection. The antibiotics choice is also very important during the selection part if you want to do stable line selection, right? So this is the 2 things the antibiotics will actually affect. But overall, I'd like to say the antibiotics does not really affect the transfection efficiency. But if you can try not to use antibiotics, you actually eliminate one factors. Yeah.
Okay, and another question. Thank you so much for all the questions. Please keep them coming. We have a couple of minutes left, so
No problem.
It's coming. All right. A question from Benjamin. How can you know that the transfected culture cells are still viable in case no contamination is observed?
So I think the easiest way, of course, is to if the cell grows. If the cell grows and proliferated, I mean, as normal, then I think the cells are still viable, right? But if you already notice that the morphology changed dramatically, they start to like become a ball shape and they stop growing, just don't look nice, then obviously it could be the viability of the cells is somehow affected. Yeah. Yeah, that's my answer. Hope. Yeah.
And another question from I hope I pronounce this correctly, Mr. Chen La. In case we want to transport or ship cells in 96 well plates immediately after doing transfection with neon, what should we do to protect ourselves?
I don't. What do you mean by transport the shipping the cells? So you mean you? Okay. So if you mean that you do electroporation and you want to immediately like send it to somewhere else, right?
That's
Okay.
correct.
So yeah. So honestly, I don't really have such experience, right? But what I would suggest is that you just make sure that the media is changed back to the normal culture media, right? Because you don't want to expose the cells into the electroporation media for too long, right? And of course, you have to keep the cells. I mean, I don't really suggest that you ship the cells like immediately after electroporation. I really suggest that you at least keep the cells in the incubator to like make the cells more comfortable or like recovered from the harsh electroporation before you do transportation, because normally transportation of cells really requires 4 degrees, right? Which is also another harsh environment. Yeah. I hope I answered your questions, but honestly, I'm not really experienced in that particular situation. Yeah, thank you.
Okay, and a question from Josephine C. The lipofectomy recommended 2.5 nanogram of DNA. Is there a recommended volume? How much DNA per microliter?
Okay, so basically, like I said, it really depends on the cell type. And as I mentioned in my slides, we actually have this protocol calculator, right, which you can really use online. So you just select the transfection reagents and the amount of DNA, then the system will give you automatically calculations. But again, as I mentioned many times in my presentation, you really have to do optimizations before you decide which ratio, how much volume of DNA or the volume you use. Yeah, I hope I answered your questions.
Okay, I think we got all the questions. We have about 1 more minute. Maybe keep the questions coming. And in the meantime, I'll hand it over to Sonia to do the poll. Over to you, Sonia.
Okay, thank you, Lydia and Zoe, for the wonderful presentation. Hi, Lydia, can you hear me?
Yes, yes.
All right, great. So right now it's poll time. So as mentioned yesterday in our first session, please participate in our poll because you will stand a chance to win the UV sanitizing box at the end of during the lucky draw later. All right, so everyone, I will encourage all of you to look towards the right side of your screen and participate in our poll. Okay, in this poll, we have around 6 questions. So just quickly take 5 minutes to complete the poll before we proceed to the lucky draw. And we hope you have found Zori's presentation useful for you and hope you have great takeaways from today's session. But if you still have any other questions, like you might want to have a further conversation with our Thermo Fisher technical and sales representatives, please also indicate in the questions below so that we can follow up with you closely. And of course, for Southeast Asia customers, please share your interest with us because we will follow up with your distributors as well to reach out to you. And of course, if you have any other questions which might be relevant for Gibco, but not so relevant for Transfection, please include in question 7 and write down in the chat box. All right, this poll will be open for around 4 minutes. So please help us to participate in this poll, and then we'll proceed for the lucky draw very soon. All right, and our speaker will also be with us until the end of today's session. So if you still have other burning questions that come to your mind, please go to our Q&A box and we'll be monitoring the chat box and answering you. For those who have completed the poll, I would encourage all of you to stay on because we'll be doing the live lucky draw. And if you are the winner, we'll be announcing your name and then you will stand a chance to win. So this lucky draw is applicable to all participants who have attended this webinar. So we thank you for your joining us this Friday morning and afternoon. All right, for those who are unable to see the poll, you might need to actually open up the tab because it could be collapsed. So you might need to click on this arrow, which is on the top left beside the word polling, and then you can expand the poll. Okay, if you still cannot see the poll, please write to us in the panelist chat, okay? And let us know and how we can support you. Okay, for those who have completed, you guys can actually take a quick short break before we come back for the quick lucky draw. We'll start the lucky draw very soon. All right, so today's Gibco Galaxy Tour Day 2 is the part 1 of our September series. So we'll be having a October series, which is happening in actually 2 weeks' time. All right. We'll share a bit more about the event that's happening in October very shortly as well. All right, so for those who have completed, maybe let me just share my screen. All right, I hope that everyone can see my screen. Yeah, all right. Okay, this is Gibco Galaxy Tour 2. So I just want to emphasize that this is also a very important webinar that we have planned out for you. It's actually a 2-day event in October. So for those of you who are working on the cell and gene therapy field, you do not want to miss this seminar because we have a series of lineup of speakers which will cover a very interesting topic about regulations. And also on 8 October, we are launching a very exciting product which I'm personally very excited about. Okay, it's called Rotier, Gibco Rotier CTS system, where our speaker Jacqueline will be launching it virtually across Southeast Asia, Taiwan. All right, so you do not want to miss that session. And also for Taiwan customers, on 8th October, we'll also be having a Mandarin session for you after the English session. So please, you do not want to miss this session. So for those of you who have not registered, I will encourage all of you to scan this QR code or go to thermofisher.com/GGT2020, and then you can stand a chance also to win some exciting prizes that we'll be having at the Gibco Galaxy Tour 2. All right, everyone. So, all right, let's take a look at a poll and see how many of you have completed. Okay, we'll just take a couple of 1 more minute, 30 seconds left for everyone to complete the poll. All right, so for those of you who have missed the poll, not to worry, we'll be sharing a general marketing email later in a Q&A box. So you guys can also email us All right, the email is actually events.sea@thermofisher.com, which we will write down in the Q&A box, okay, for you. So I understand some of you might have missed the poll. So if you have any other questions, please write down and email us at events.sea@thermofisher.com. Okay, and for those of you who have not registered for our Gibco Galaxy tour in October, please maybe also share this event with your lab members for if you think this is relevant for them, right? Because cell and gene therapy is a very key focus for this year and for most of researchers. So you do not want to miss this session. Share this with your lab mates or your PI, all right? And then you all can attend this event together. Okay? You guys can log on to thermofisher.com/GGT2020, and there's also a lot of other literatures that we have embedded in the website, and we've also included our cell biology portfolio brochure. So please go to the website and download all the resources. Okay, and do note that this webinar will also be on demand. So this has been recorded. So if you find today's 2 days event very useful, yesterday we had Dr. Deborah to cover about cell culture basics, as well as David, who covered about sample management, and today we have Zoe, who covered about transfection. So all this will be recorded, and if you think that you might want to revisit again, you can watch it on demand and also share it with your lab friends whom you think will benefit from today's session. All right, once again, Gibco Galaxy Tour, it's our yearly event, and I hope that you guys can actually benefit from this, and we hope that you guys can learn as much as possible from these sessions. Okay, and very soon we'll move on to the lucky draw, so I will encourage everyone to stay on for a bit while we get ready for the lucky draw wheel, okay? Yeah. All right, you guys can take a short water break. Okay. Just give us some time. And if you have any other questions for Dr. Zhou, he's still here with us. Okay, so please write down your questions into the Q&A box. Okay, you do not want to miss the chance to have a live Q&A where you can get instant answers for your burning questions, okay? All right, I'll just leave this slide open once again to promote this Gibco Galaxy Tour event that's happening in October. So it's on Wednesday and Thursday. So you just need to take a short morning away from your lab work to join us virtually.
Hey, hey Zhou, sorry to interrupt, Sonia, but the question came in.
No problem.
Question for you, Zhou. Is transfection optimization really necessary?
Oh, yeah. So like I mentioned, it is very necessary, right? So because there's so many different factors really affect the transfection results, right? It could be the cell types you're working on, it could be the payloads, right? The DNA, RNA, or proteins, the size of the DNA, RNA, and also the concentration of the cells, so many things, right? So you really just to, I mean, for the sake of saving your money, you really need to do optimizations in a smaller scale before you actually work on your precious samples, right? So yes, the answer is yes, it's very necessary. Yeah.
Thank you, Zhou.
Thank you.
All right, do we have other questions coming in, Lydia?
No, I think those are all for now. Yeah, we have
Sure.
some time still, so please keep your questions coming.
All right. Okay, everyone, if you still have any questions, please proceed to our Q&A tab and just key them in, all right? If not, you can also email us at events.sea@thermofisher.com if you are unable to see the poll. Okay, everyone, I think ready for lucky draw. Okay, so today's draw is very exciting. I think for those of you who attended our event yesterday, you guys participated in 2 polls already. So today will be a 3rd poll, and it means that you guys have triple the chances of winning the UV sanitizer box. Okay, and we'll be selecting 4 winners across the region to win this prize, and we'll be sending the prizes to you after this event. So for those of you who are not based in Singapore or Southeast Asia and Taiwan, so we will be sending the gifts over to you. So please give us around 4 to 6 weeks to deliver the prizes to you. Okay, all right, everyone. We'll proceed with lucky draw right now. Hi, Shia, over to you to share the lucky wheel. Okay, everyone. I hope that all of you can see the lucky draw wheel right now. Okay, and let's go for our first winner of the day. All right, let's see who's the lucky winner. So we have a lot of names on this wheel, as you can see. Let's see who's the lucky winner for today. Okay, our first winner is our customer from Vietnam. Okay, Miss Quang Bui, congrats. We'll reach out to you after this event as well. Congratulations. Some virtual applause for you. Okay, let's move on to our second winner of the day. All right, and that's Amiru Nazan. Congratulations. I hope you are still here with us at this event. Please give us a shout out if you are still here, all right? Okay, and we'll reach out to you after this event. All right, let's move on to our third winner. Okay, eyes on the prize. Let's see who's the lucky third winner for the day. Oh, congrats! We have another customer from Vietnam again, Mr. or Mr. Nguyen Phong. Congrats! All right, congratulations. And we've moved on to our last winner. Right. Who will win the final UV sanitizer box? Oh, okay, and our winner is Ma Teresa. Congrats to you. All right, that's very exciting. We've come to the end of our lucky draw session as well. So just to recap again, our 4 winners are Miss Quang Bui, Mr. Amiru Nazan, we have Yuan Fong, as well as Ma Teresa. All right, congratulations to all 4 winners once again. Okay, we're applauding for you. Okay, great. So yeah, we'll leave this window open for around 10 minutes, and we'll still be around. Dr. Zhou will still be around as well. So if you have any questions, please type in the Q&A box, and our panelist Zhou will answer and get back to you as soon as possible. And with that, I think you've been a wonderful audience. We just want to thank you for your time, and thank you for joining us in our 2-day Gibco Galaxy Tour 2020. All right, and thank you so much once again. And for those of you, I think everyone is lunch soon. All right, so please enjoy. All right, and then stay tuned, and we'll see you at our next event in October, and our Gibco Galaxy Tour 2 in 7 to 8 October. All right, thank you everyone, and have a good weekend ahead. Thank you. All right, we will now share the slide for Gibco Galaxy Tour 2 for those who are interested to sign up for the event. Thank you very much. All right, let me just share. All right, everyone, if you still have any questions, please key into the chat box. We'll close this event in 5 minutes' time. All right, but if you want to stay on to enjoy the music, please go ahead. Okay, so for those of you who are still on the line, please take out your mobile and scan the QR code and register for our Gibco Galaxy Tour 2 in October. All right, we look forward to seeing you there because there will also be more lucky draws coming in. All right. So thank you all for joining us for our 2-day event and supporting us and being hopefully all of you are our Gibco loyal fans, okay? Please continue to support Gibco because we are the market leader for cell culture and cell therapy systems, okay? We definitely appreciate all of you for joining us. We look forward to seeing you at Gibco Galaxy Tour 2 in October. Please register and share with your lab mates, and y'all can attend this event together. All right, with that, we'll be ending this event shortly. And thank you and enjoy the music.
Hello, this is Shreya, your technical host for this webinar on GGT2 Gibco Galaxy Tour 2. Thank you for attending Gibco Galaxy Tour 1. So see you on 7 and 8 October for Gibco Galaxy Tour 2 and hope to see all of you there. And I'll be ending the session right now. Thank you and hope you will have a great day and a great lunch. Thank you, everyone.